Hey guys, so today we're going to talk about function notation and everything that kind of leads into. All right, so for your warm-up, we're going to look at the same graphs that we looked at before. So we have a dog owner, and he leaves his dog tied up for some amount of time. Day one, this graph is showing that the dog walked around the entire time after the owner left. Day two, the dog walked around, and then after the first minute, laid down until the owner came back. Day three, the dog followed the owner until he couldn't go any further, and then walked around the post in circles until he ran out of leash. So what I want you to try to do is fill in this table on your own. Okay, so let me move this box over here. So fill in this table for each day. So how far away was the dog 60 seconds after the owner left? At the exact moment that the owner left, 160 seconds after the owner left, and then how many seconds passed before the dog reached the furthest point it could from the post? All right, hopefully you had a chance to do that. So you can check your answers here. If you weren't sure how we got those answers, so for the first one, if we're looking at 60 seconds after the owner left, you had to look at the graph for each day. We start at the origin, you go over to 60 seconds, and then up to where the graph touches the line, and you can see that it's at 4 feet. For 160 seconds, you would have gone over to 160 and across, and it's about 3.7, 3.8. For the exact moment that the owner left, you would look at 0 because the owner, the time is time since the owner left. So that would start at 0. Hopefully you got those right. If we were talking about each day specifically, it would have one column. But if we're just asking these questions, it might get a little confusing if you don't mention which day we're talking about specifically. So considering these statements, the dog was 2 feet away from the post after 80 seconds. Do you agree with this statement? All right. So you might agree with this statement if you're looking at day 3. But if you're looking at day 1 or 2, the dog was not 2 feet away from the post after 80 seconds. So it's only true for day 3. Okay. What was the distance of the dog from the post 100 seconds after the owner left? Well, you would go to the graph and look at 100 seconds after the owner left. And you can see that all 3 days are different. So day 1, it was about 2.2 feet. Day 2 was about 4 feet. And day 3 was about 1.25 feet. So hopefully you were able to find those points on the graph. But again, you have to specify which day you're talking about because the dog was not in the same spot every day at 100 seconds. So that's where function notation comes into play for us. So over on the right, I have the graphs that we were using just in case you want to look at them. But if we want to know a specific number of seconds after the owner left and a specific day, it might be useful for us to give them a name and write it in shorthand. So we're going to label function f as day 1. So day 1 is now going to be known as f. Day 2 is going to be function g. So we're going to label it G. And day 3 is going to be H. So if I want to know the distance from the post 60 seconds after the owner left for day 1, instead of saying that sentence over and over for each day, I can just know that it is F of 60. So in the parentheses, I put 60. And 60 represents the seconds after the owner left. So F tells me it's day 1, and the 60 in parentheses is the input because time is almost always your input, and then it's 60 seconds after the owner left. If I want to look at day 2, I would just say G of 60. And I would know that that is day 2, 60 seconds after the owner left. And it is a lot faster to write that than to say distance from the post 60 seconds after the owner left on day 2. or 60 seconds after the owner left on day 1. And likewise, if I want to know day 3, I can just write h of 60. Okay. What if I want to know the distance from the post when the owner left on day 1? Well, what time did the owner leave? If it's time since the owner left, it would be 0 seconds. So I could just write f of 0. If I wanted to know day 2, it would be g of 0. And day 3 would be h of 0. Then distance from the post, 150 seconds after the owner left, would be f of 150. G of 150, h of 150. So I could just use this shorthand or this function notation to know exactly which function I'm talking about, day 1, day 2, or day 3. Okay. We can also understand what the function notation means by kind of describing it in words if you need to. So for our context, if we have f of 15, we would look and say, okay, well, f represents day 1, and 15 is 15 seconds past when the owner left. So that would represent the distance from the post 15 seconds after the owner left on day 1. Okay, see if you can figure out g of 48. All right, g of 48 would be on day 2 instead of day 1, so it's the distance from the post 48 seconds after the owner left on day 2. And h of t would be the distance from the post t seconds after the owner left on day 3. Okay. Now I want you to take a minute and look at the difference between g of 120 equals 4 and our expressions at the top. We now have an expression set equal to the distance. So it tells us the distance that we have. So g, we know that g is going to be day 2 because g is day 2. And then inside our parentheses, our input is 120. And 120 seconds is the time after the owner left. And then it is set equal to 4. 4 tells us that the dog was 4 feet away from the post at that time. Okay, so we can know what this equation is talking about based on the situation. So if we were given h of 40 equals 4.6, we would say, okay, h represents day 3. So on day 3, and 40 is the time or the input, 40 seconds, and then 4.6 would be the feet the dog was from the post. So we would say on day 3, the dog was 4.6 feet away from the post, 40 seconds after the owner left. Okay, try B. Right? B, we would say that on day 1, because F is day 1, the dog was 5 feet away from the post, T seconds after the owner left. And C, if we had G of T equals D, we would say that on day 2, the dog was D feet away from the post, T seconds after the owner left. All right, so this is something you probably want to write down in your notebook. Make sure that you have this somewhere so that you understand what function notation is. So if we were given f of t, or it could be f of x, f just represents the name of our function. We used it as the number of days. It was either day 1, day 2, or day 3. And we assigned them different variables. So the letter here is just the name of your function. What's in parentheses is your input or your x value. Remember, your x value is your input. Okay? And then the whole thing together is your output. So it gives you your answer. That's what you set it equal to. And your output is the same thing as your y value. Okay. So for our example that we had, we might say f of 60 equals 4. Where 60 is your input, so your input or your x value equals 60, and your output or your y value, what you get out of it, is 4. So that told us that after 60 seconds, the dog was 4 feet away from the post. This also lets you write it as an ordered pair. So remember, ordered pairs are x comma y. Well, I have an input, I have an output. So I have an x, I have a y. So I can write that as 60 comma 4 and find that spot on a graph. All right, so let's look at this another way and try to kind of relate this to functions. So if I have rule B and it takes a person's name as the input and gives an output of the person's birthday. So Abraham Lincoln is born February 12th. Okay, you can pick someone else as your input. So let's see here. John, December 3rd. Ava, April 13th. So if I have a specific person as the input, how many possible outputs are there? Okay. Well, there's only one, because a person only has one birthday. They're only born one time. So you're only going to have one possible output. Nobody has 2 birthdays. They were only born on one specific day. Okay. What about rule P? Rule P, it takes the person's date, their birth date, and gives a name as the output. So if I picked December 26th, I might get Justin and Bradley. Or if I pick June 28th, I might get Erica and Carrie, which that's my birthday, and Carrie was a friend I went to high school with. We had the same birthday. So if I put in a specific date, I might get more than one possible answer. So there would be multiple outputs because many people can be born on the same day. There are 365 days in a year, and there are millions of people. So it's bound to happen that someone is going to share a birthday. And you have a set of twins in your grade, which are born on the same day. So one date, 2 outputs. Okay. Only one of those relationships is a function. The other one is not. Which one? Okay. So the one that's a function is rule B. Rule B is a function because each input or person has one specific output or birthday. The other one is not, because you get multiple outputs for the same input. For the relationship that is a function, we can write that as an input-output relationship. So for John, I think, let's go back. So I might say that F of John and his birthday was, so F of John equals December 3rd, or the other ordered pair would have been F of Ava equaled April 13th. So my input is the person's name. The output is the date they were born. So I have an input of John, output of December 3rd. Input Ava, output April 13th. So hopefully you understand how to write function notation. It's just a shorthand for writing a function and identifying different ones when you have multiple things and functions that you're looking at.